All right, so in this chapter, what we're going to look at is inequalities. Now, an inequality states that two quantities are not equal. Inequalities are written using the following symbols, which you should remember, and that is less than, greater than, less than or equal to, greater than or equal to. And just remember, there are different ways to remember it. Some people use analogies like drawing an alligator or a shark or something. Whatever it is that will help you to remember that would be good. I think one of the most practical ways is that simply the inequality is shaped so that the smaller side is pointing to the smaller value and the bigger side is facing the bigger value. Now that's important because in Algebra 2, a lot of times it's rewritten. It's not always written in the easy to read format. All right, so let's look at how we could just write these numbers in correctly. Decide which inequality will satisfy the following relationship between the numbers below. All right, so which one would go in between that? You can answer on your own. Pause the video as well. All right, so 4 is what than 15? Well, we know it's greater than, and so it's just which symbol. And the greater than symbol, is 15 is greater than 4. So we know it's less than, and so we know the less than symbol. So we know that the 4 is less than the 15, so we want to choose the less than symbol there. And so less than goes in between. Look at the inequality is pointing down to the small number and opening up to the bigger number. All right, this one just tests your abilities for integers. Which one is the smaller number or the greater number? Which way should it face based off of the numbers that are here? Well, negative 5 is larger than negative 85, so we want a greater than sign. And then the last one, we have 15 and negative 15. Which one is greater? 15 is greater than negative 15. All right, and so we wouldn't use the greater than or equal to in these two because they're just two comparison of numbers. But we do utilize these two with algebra, and that's what we want to look at. All right, so the graph of an inequality on a number line shows all the possible solutions. Remember, solutions are the answer once you solve an equation. And so inequalities can have solutions as well. So when graphing an inequality, what we want to do is use an open dot to represent the greater than or less than, and a solid dot to represent the less than or equal to or greater than or equal to. So what we do after that is on a number line, we're going to draw an arrow from the dot into the direction that includes all our possible values. All right, so what does that look like? Well, let's use x less than or equal to 4. On a number line, the first thing we would have to do, as stated, is to put a dot, open or solid, depending on the inequality, at the number. Since it says x is less than or equal to 4, that means we want to have a closed circle or solid dot at 4. And then we just need to decide which way the arrow goes, and that's just based off of the less than or equal to. When it's written in this format, it makes it easy to see which way the arrow goes. And so it's obviously less than the 4, and so it would basically include an infinite amount of numbers that are less than 4. But also, since it includes 4, we circle in the dot. All right, how about this one is rewritten in a different format. Many times in Algebra 2, it can be written backwards, and this is why it's good to understand the inequality symbol. So this reads negative 1 is less than x, but if you read it from the opposite direction, from this way over, then you say x is greater than, right? See the greater than part. X is greater than negative 1, which means you could rewrite it as x greater than negative 1. You just have to remember which side is the bigger number if you rewrite it. Now that you do that, we can put it on a number line. What type of circle would be at negative 1? Would it be a closed circle or an open circle? Well, here we see it's an open circle because we are not including the negative 1. And then from there, we just need to decide which way. Since x is greater, it would be all the values bigger than negative 1, which would be to the right. And so every number from negative 1, and after negative 1, on the number line would be included in the solutions there. All right, but then we also get the algebraic aspect of it. And so here, what we're going to do is just show how we can write a linear inequality in one variable and solve it. So here are some examples. We have x plus y is less than or equal to 4, and negative 3 and subtract 5 greater than 4. Now, the rules to solving inequalities are very similar to solving a regular equation. However, there's one rule that differs, and that's when we're multiplying or dividing by a negative number on both sides. So let's take a look using that second one. We're going to do two different examples here just to help you understand the different process that can happen. So let's solve the left one here in a way where most people do not like to deal with the negative numbers. Now, if I don't like negative numbers, what I can do, I can add the 3n on both sides. And what I do to one side, do to the other. Now over here on the left, the 3n's cancel. I'm left with negative 5 is greater than 3n plus 4 since addition is associative. Right? And then we could bring the 4 over because I want the n by itself. And so negative 4 subtract 4 would give us negative 9 greater than 3n. And then we could divide on both sides by 3. And we get negative 9 divided by 3 is negative 3, which will be greater than n. And so on the number line, we can see clearly that where our numbers would go. But first of all, let's see what would happen if I did not change the negative, which is really less steps. Now, if I didn't change the negative 3n to the other side, but instead move the negative 5 by adding 5 on both sides, we're going to get something slightly different when dealing with inequalities. So here the 5's cancel. We have negative 3n is greater than 9. And then we divide both sides. We want n by itself, so we divide by negative 3. Now when we do that, look what happens here. That is not the same. That says n is greater than negative 3, but here it says n is less than negative 3. And this is where that rule comes in. When you're dividing by inequalities, if you divide both sides by a negative, or you multiply both sides of the inequality by a negative number, what you have to do is actually switch the orientation of the inequality. And so when you switch the inequality, what we'll get is n is less than negative 3. So remember that's the rule that we want. And when we get n is less than negative 3, now these two will match, they will equal. And so what we can do now is simply graph them on a number line. And I'm just going to have to erase just this part here so it fits nicely. All right, so now what we have, if we is to put this on a number line, is that n is less than negative 3. So negative 3 is about here, right? It's an open circle, and because it's less than, we go in this direction with an arrow to show that it keeps on going. All right, so just remember this rule here. We'll recap on that. That multiplying both sides of an equation by the same negative number will reverse the sign of the inequality. And the same goes with dividing. If you divide both sides by a negative, then you will reverse the sign of the inequality. And this should say actually inequality as well. All right, so let's go ahead and try some other examples. What happens when we get variables on both sides of an inequality? Well, we can do either or. We can try to eliminate the negatives so that we don't have to worry about reversing the sign. Or we could just take the shorter route, and if the shorter route means not doing that, then you can go ahead and do it. All right, so let's move. I'm just going to move the positive 6x. I'm going to say plus 6x, just because I traditionally do not deal with the negatives with variables. So that cancels out and leaves me with 4x plus 3 is less than or equal to negative 1. I could subtract 3 on both sides, and what we get there, they cancel, and I have 4x is going to be less than or equal to negative 4. Divide both sides by 4, and now I have my inequality that x will be all values that are less than or equal to negative 1. And if I was to put this on a number line, what you'll see here is that I will go to negative 1. It's a solid dot there, right? I will fill that in because I am including the value of negative 1. And then it's all my values that are less than, and I show that by putting an arrow in the direction of the values that satisfy. So negative 2 could be a value, negative 2.5, negative 4.8, etc. All right, so now let's look at this. This one actually comes straight from the book. And this one says the weight W in pounds of an Icelandic saith is given by w equals to 10 and 4/10 times t, subtract 2 and 2/10, where t is the age of the fish in years. Describe the ages of a group of Icelandic scythe that weigh up to 29 pounds. All right, so in order to do this, we need to substitute our 29 pounds into our equation. But our equation is going to have to be an inequality now, and that's because we're looking at weighing up to 29 pounds. And so that means my weight as an inequality has to be less than or equal to 29. Since w is less than or equal to 29, that means my equation here can be set to be less than or equal to 29. So I have 10.4 t subtract 2.2 has to be less than or equal to 29, since that's equal to the inequality. Now we can go ahead and solve this inequality. So if I add 2.2 on both sides, what will happen is my 2.2's will cancel there, and I'm going to have on the left side 10.4 t is less than or equal to, now 29 plus 2.2 is going to give you 31.2. And so then we can divide both sides by 10.4. All right, so those cancel, and I'm left with t is less than or equal to, and just could use your calculator here, and that's going to give us 3. So that means the age of the fish has to be less than 3 years of age in order for it to be less than 29 pounds. So now we're dealing with compound inequalities. Now a compound inequality is comprised of two simple inequalities joined by and or statements. So here in the first example, we see a scenario here with and so how it would be read is that x is greater than -3, and it is also less than or equal to 2. And so if we were to graph this on a number line, we see that -3, we're going to have an open circle since it has the less than sign, reading it from left to right. And then x is going to be in between that and ending at 2. But because this x is less than or equal to 2, we know it's going to be a solid dot because we're including the 2 in our solution. And so all the other numbers that are in between, we represent that with a line. And so the line is connected, and there we have a compound inequality. Now on the other side, we have the same numbers, but this time it's or. Because x is less than -3 or x is greater than or equal to 2, we have the two extremes. It's going in either direction. And so we're not including anything that's in between. There's no intersection if you've ever done Venn diagrams. And so we use the or statement. And because it's an or, you see what this looks like visually. At -3, it's an open circle since it's x less than -3. And because it's less than, it goes in the opposite direction. And for +2, x greater than or equal to, it would be a solid dot since we're including it with the equal sign. But then when we draw the arrows, we see they go in opposite directions because they are or statements. There's no intersection, nothing included, nothing in common in the middle. All right, so now let's do an example with an and compound inequality. And so here's an and statement. And so what we're going to see here is that we can graph this in a way where we see the two extremes and all of our numbers in the middle. So let's go ahead and solve this. Remember, whatever you do to the middle, you will do to both sides. So because it's addition, the opposite operation is to subtract with the same number. And what you do to the middle, you will do to both sides as you're doing them simultaneously. All right, the 8's will cancel, and -4 subtract 8 will be -12, less than or equal to 6t. And on the right side, 20 subtract 8 is going to give +12. And then to get the t by itself, do the opposite operation of the multiplication there and the same number. And what you do to the middle, you do to both sides of the inequality there. All right, -12 divided by 6 is going to give us -2 and a t in the middle. And +12 divided by +6 is +2. And so on our number line, we will have a closed circle at -2, a closed circle at +2, and the and statement letting us know that all of our values could be in there. So possible values could be -2, -1, 0, 1, or 2 as integers. Now some questions, they try to throw in other concepts, so they might ask you what integers can be within there, or they might ask what whole numbers could be in there. If they ask you what whole numbers, then it's 0, 1, and 2. If they ask you what integers, it would be -2, -1, 0, 1, or 2. Right? So if you ever get a question like that on like an entrance exam or anything of that nature, just be careful of the wording. All right, so now let's look at example 5 with an OR compound inequality. And so here we're going to solve for two different ones, and they're just being basically used at the same time. So I'm just going to solve them straight from what's written. So we're going to add 3 just like we would with any other equation. Remember, similar rules they have. The 3's cancel, and so we have 5x is less than 10. We divide both sides by 5 as we have learned previously, and x is going to be less than 2. On the other side, I've just changed the color here. We're going to do the opposite operation, same number. What we do to one side of the inequality, we will do to the other. The 7's cancel, you're left with 2x, and bring down that inequality. And -2 plus 7 is going to give 5. All right, and so if we divide both sides by 2, we're going to get a decimal there, or a mixed number, or just leave it as an improper fraction. But since we want to graph this, 5 divided by 2 is 2 5/10. And so if we were to graph that on a number line, for the first one, an open circle, it's going to be at +2. And because it's less than, it will go in this direction. And then at the positive value, they're both positive, but at the bigger value, 2.5, 2.5 is about right here, and it will go into the opposite direction. Can't really see that arrow as the colors match, but you can see my little lines there. So that means between 2.0 and 2.5, we have values that are outside of that. And this is where it leads up to our problem solving, things such as outside of the tolerance zone or within the tolerance zone. And so you can see right in there, these don't satisfy, but every other number will work. So keep that in mind when you do problems.